Hello everyone again, this is Indrik from Czech DC-9 project. Today with the Autopilot automatic pilot control panel, which is now completely done. The last thing that was not working was the automatic movement of the vertical speed wheel here. So in fact it works that way. If the servos are disengaged, the vertical speed wheel is automatically putting itself into climb descent mode according to the vertical speed that the aircraft is currently flying. So for example, on a takeoff, once the aircraft starts to climb, the vertical speed wheel will go to a climb. And then when you turn on the servos, the selector is actually moved into the vertical speed, because you cannot select anything else. So the vertical speed wheel is controlling the actual climb of the aircraft. That's why this wheel must move according to the vertical speed that the aircraft is flying at that moment. That wheel also moves automatically when the ILS mode is selected, and on mine glide path you are controlling the glide by the vertical speed yourself. So that's why I will now show you. Have the aircraft started, as you may see there on the computer, and I will perform a takeoff, and you will see something wrong. It's the takeoff warning. Why? I don't know. Okay, so we are on the roll. Speed is 80 now. Rotate, I will start to rotate the aircraft, and soon the altitude, the vertical speed wheel will try to go down.
Rotate.
As the aircraft will
V2.
climb.
V2 plus 10.
We're climbing now. Here it makes a lot of noise. I'll make it to
localizer capture.
About 2,500. And now I'll select the IS hold. Oh, sorry, I will set the autopilot servos on. And you can now control the vertical speed by the wheel. And I will put it into IS hold, so that it will hold the indicated airspeed and will climb to as fast as it can. And I'll turn on the autopilot heading so that we are flying to the pre-selected heading. You can hear it also makes lots of noise. I want to speed up a little bit, so I'll put it to 1,000 climbed only. Once the aircraft speeds up, I will make it climb speed about 240 knots.
Flaps up, slash retract.
The flaps. And once I turn the IS hold again, it will stay for a while on the 1000, and then it will start to climb again. 3000 is maximum the wheel can do. You see there is the end of the scale and there is the descent already. So if the aircraft is actually climbing more than 3000 feet per minute, it will not show because there are no numbers. I'll climb to 6000 feet, which we are already reaching, so I will put it into 1500 again. Now I'm controlling the vertical speed. And okay, we're now at 5900, 6000 feet. I will put it to alt hold. That means that the aircraft is keeping our altitude. Once we are about 15 miles away from the touchdown, I will turn the aircraft into the localizer. Now I will show you also the other direction. I will put the engines to low thrust and put the IS hold, so it will now start to descend. And then the motor behind is controlling the vertical speed wheel to a descent according to the vertical speed that can be read from the VSI. I'll put the engines to idle thrust. This can go up to 5,500 feet descent. It's only 1000 something. If I put the gears down, it will start to descend more rapidly.
You're down and locked.
Put gear up and it will
You're up and locked.
stop descent again. About to reach 4,000 feet, so I will again, once I move with this wheel, the selected pitch is automatically turned off. So I'll put the zero climb, the altitude hold mode again, and I can now turn into the ILS. I'll need to use the mouse because we are, as our workshop is undergoing reconstruction, I'm way in a small office where I can do things.
Slats extended.
Reaching the slat speed. I'll try and need to put more thrust. I'll turn off the heading selector, and I will turn the aircraft using the turn up. So that's the amount you want the aircraft to turn. That's 30 degrees. That's the 30 degrees turn to the right. If it's up, it's level. Okay, so I can now stop the turn. I don't know if you see it on a computer, maybe you can see the HSI, but it is actually controlling the aircraft. And once we have the localizer captured, I can turn it now to nav lock. Still nothing will happen with the vertical speed wheel because Navlock doesn't control or pitch, only the glides. Once captured, will also control our vertical speed, so then the vertical wheel will move again. Okay, we are now the localizer, and once the glide slope is moving now,
Localizer capture.
I will set it to ILS, and now also the vertical speed wheel is controlled by the air data computer. So once it's one dot away from catching the glide, and it will start to descend any moment, and it should stop at about 700 feet per minute. You see, we have now the glide slope is captured and the aircraft is descending. So again, if you
Flaps 5.
they're a little bit fast, that's 220 knots, so the descent is more quick. That this mark is 1000, 1500, 2000 feet minus. So we are slightly more than 1000 feet, but I will now make configuration for landing, and the descent rate will stop at about 700
Flaps
feet.
15.
Yeah, set the flaps, the aircraft starts to let's say climb.
Flaps 25. Flaps 40. Feet.
To stabilize, and it's about 700 feet of descent rate. We are
500 feet.
1 mile away from the touchdown zone.
300 feet. 200 feet.
Turn off the autopilot now.
100 feet plus 100.
50, 30, 10.
We're on the ground, so zero pitch game. So that's the demonstration of the
Parking brake set.
the autopilot control panel, which is completely done at this moment. Maybe I will find some errors later, but for me it's working good,
60 knots.
and it's ready to be mounted back into the aircraft. So that's it, guys. Thank you for watching, and see you next time. Bye.